Hi friends, welcome to follow up. Let's have a look at problem 2917. Find the key-all of an array. This is an easy problem, and indeed its logic is very straightforward. So here we are going to practice the task of checking if a bit position is set or not. So we are going to practice using the bitwise operation. So here the problem is the following. So we are given a zero-indexed integer array called nums and an integer key. The key-all of nums is a non-negative integer that satisfies the following condition. So we are going to see the ith bit is set in the result if and only if there are at least key elements of nums in which the corresponding bit I is set. So we're going to return this key-all of the nums list. So it gives a note. So a bit I is set in x if 2 to the power I and or x is going to give us 2 to the power I. And here add is the bitwise add. So here we have 3 examples. I'm going to look at the first one to digest the requirement. So here, if you look at the the 7, 12, 9, 9, 8, 15. So the here we have a column representing the array itself, and the right hand side represents the corresponding binary representation. So here the count of the key is 4. So if we consider each bit, if there are 4 numbers have this bit set, so we are going to set the corresponding bit in the result as 1. So if you look at the rightmost bit, we have 4 numbers set, so this is going to give us 1. And if you look at the first and second from counting from the right, so they are not set because in the first index, so they're going to have 2 is less than 4, and in the second it's going to set 3 is less than 4. The most significant position, it has actually 5 numbers have this bit set, so we get 1. So 1001 corresponds to none. So this will be the return for this problem. So now we are going to use this one to do the problem. But here is we want to effectively check if a bit position is is set or not. So there are 2 ways. So 2 equivalent ways, I would say. So for a let's use the here. Let's see, you have x. If you want to check if the bit at ith bit is is set, so we can do this, right? So this should be equal to 2 to the power I, right? It's corresponding to this is 2 to the power is going to move to the left, right? So this is just another way of writing, because this is nothing but x add 2 to the power I equals 2 to the power I, right? Just writing using this arrow notations. So similarly, you can do this. So x, so if we divide it, so move to the right by I unit, so I can be 0, right? So then it's add with the 1. So if this equals 1, actually it corresponds to seeing that the ith bit is set. So this is actually equivalent to say x integer division by 2 to the power 2, then exclusive all with not exclusive all, and bitwise add with 1. It's going to be 1. So you can do both, but here I'm going to use this one. So now we know that from the constraint, so this length is very small, right? It's 50, and also each number has at most 32 bits because it's bounded by 2 to the power 31. So we are going to check this each position, right? To see, I'm going to use a 0 times 32. And then we want to check for each bit if it's set or not. So for I in range 0 to 31, right? So we want to check if the ith bit is checked. So I'm going to use a temporary sum. It's a sum. So I'm going to check if the ith bit of this number a, so and 1, if this equals 1. So if it's equals 1, so or it's just a 1. This is either 0 or 1, right? If it's 1, it means set. So I'm going to do a comprehension for a in nums, right? So if temp is larger than or equal to k, and then the corresponding bit in this check table, let's use 32 minus 1 minus I, and then it's going to be 1, right? So we can print out this one corresponding to this example. We know the fourth one and the zeroth one and the third one will be set. Let's print this out. So you can see, yeah, we have this one and this one, right? Then we just need to transform this check into be a decimal number. This is super easy, right? So we're going to have summation check I, then times 2 to the power 32 minus 1 minus I, right? Because from the left is the most significant bit. If it's 1, it's 2 to the power 31 essentially. So here for I in range 32. So now let's do a test. Yeah, it passes the first one. Now let's look at the generic case. Yeah, it passes all the generic cases. So here I'm using this one, but you can try this one. So let's copy this part. So another way to check, let's call this one version B1. So here I do this, but you can do this. So A and 2 to the power 2, right? That's 2 shift to the left by I. So if this equals 2 shift right, left, right? So then let's do a test. So rank, let's see, here we have A and 2 to the power 2, 2 to the power I, it equals 2 to the power I, like here, right, 2 to the power I. So and so sum, so this let's see, let me first print out this check table here. So what we have, so we have this one. This is not right. So here A add 2 to the power I. Let's use this one. That's 2 to the power I. So yeah, let's see. It should be right. Let's see, 2 to the power 32. Let me. So here my set is not right. So here, let's see. Let me check this. 2 to the power I. Then 2 to the power I. Now let me check again. All right, it's right. So now let's test this one. Oh yeah. So here, let's see what we have. So if I use this operation, so 2 to the power I, right? So it's nothing but 2 to the power I. And then this is 2 to the power I. Let me see. Let me check this one. Maybe I forgot this notation. Print 2 to the power, not 2 to the power. So here, I guess what I wrote is rank. So let me correct this part. So here, yeah, I need to write this should be 1. So this means times 2 to the power of I, right? So I just need to change this one to be 1 and this one to be 1. So this one should be right. Now let's test that. Yeah, right. Yeah, that's it. So this actually also gives us a hint. So just pay attention to write the things as what in your mind, right? So now with that said, basically that's about it for this specific problem. So here we present 2 ways to check if the ith bit is set, right? So either you can use this to the power I to check, or you can divide by say a position, right? So with that said, I guess that's about it for this video. Thank you.